Okay, it is 5:25, and let's get started. So midterms are up here if you haven't picked them up. Hope you do. So Pset 2 has been out. What day is it due? Tuesday. Okay, nice. So hopefully you've all started that. We'll do the very last bit of the very last question, question 5 about Chomsky normal form. We'll finish that today, but you should be able to do all the other parts. Any questions about Pset 2? Other than the bazillions I've been getting. No, yeah.
Did you clarify what exactly the first problem is asking for?
Yeah, good question. So I'll move this down. So this was Pset 2, question 1. And so we're making a regex to recognize valid regexes. So over the alphabet 0, 1, epsilon. So epsilon here is an actual character. So you may want to insert, like, say, lambda for the empty string character, but it's your choice. So we have these characters. So we have these 4 as being characters from the regexes that we're trying to describe. These are representing parentheses or brackets, however you want to think of it, and these are representing union and concatenation. And I forgot one. It should be star as well. And star. So what we're trying to do here is we're making a regex that recognizes a limited set of regexes, those that only go one level deep in the brackets. If I allowed an arbitrary level of nested parentheses or brackets, is this language now not regular? Yeah. So if we had W to be left bracket to the P, right bracket to the P, with an empty string in the middle. If you pump the first P characters, then it's an unbalanced set of parentheses or brackets. So the whole notion of the first problem is to understand how to work with the one level deep of brackets. So here's my strategy to you. If you haven't been looking at the Piazza posts, I absolutely recommend you do. But here's my strategy. Use R from the description, because you'll be using it several times. So what can go between individual characters? So 0, 1, this empty string character, this empty set character. What can go in between every pair of them? Union or concatenation as a start. So union character, so I'm going to put a little top on it to indicate that it's the union character or the actual concatenation character. So we would have 0 concatenated with 1, union. So this is an actual union character there. Union the empty string character, then maybe we'll union again with the empty set character. All of these are possible. So noting that you can have the union character or the concatenation character between every pair, that'll get you some of the way there. Okay? Well, what else can go in between any individual characters?
Brackets.
Well, ignoring brackets for now. Star. How many stars could I have on an individual character or something? As many as I want, right? So another possible valid regex is star, star, star. All of those are valid. So, as many as I want. How do I indicate as many as I want of something? Star, the character star, but the actual regex star there. But I'll let you figure out, well, what can go in between the concatenation character or the union character? What does the or stand for? Union. The actual regex union here. All right, so that handles everything without brackets so far. What about brackets? Well, if I have a left bracket, what better I have?
A right bracket.
A right bracket. What can go in the middle, in between those? Anything that's not brackets. Oh, I have that thing already. That can go in there. But, so I'll move this, I guess, to this other side. What can go between the end of one bracket and possibly some other stuff, and then other brackets, and then possibly other stuff, and then whatever? What can go in between there? But in between individual things. Same thing, union or concatenation, or star as many times as we want. So if we fix this up, so if I have star, 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 union character 0, concatenation character 1, it's the same rules over and over again. So my advice is make a regex for this, for without brackets first, then using it, so let's call it R prime, then use R prime to work with brackets. How many iterations of this bracket with other stuff could I have? As many as I want. How do I indicate how many, any number of something that I want? Star. I'm giving away a lot of hints here, so once you understand the problem, it's not hard. I promise you. Okay? But any questions otherwise? Does that answer your question? Okay. Other questions? About Pset 2, I mean. Okay. What about, so, midterm. Let's talk about midterm stuff. So I'm going to inductively keep moving this down 17,000 pages. All right. So midterm 1. Any questions about midterm? Yeah.
Pumping level.
Okay, yeah. What about it?
Can you go over the proof for that one? Because I was confident in it, and
The solutions will be posted, hopefully when I'm not lazy. But they've been in the works, and hopefully they should be out within the next day or so.
okay.
So if you want to look at the solutions there, you can. I mean, I could go over here, but it'll be.
I guess it's just the decompositions.
Yeah. So the number, so no one got the question right at all. Because the number one thing people missed was not handling every decomposition. So, okay, you've convinced me. Let's do this. So let's look at the language. No, it was 0, 1, 1, n plus 1, 0, 1, 0 to the n, and at least 0. So let's call this guy L, and claim L is not regular. What do I do to prove it's not regular? Assume it is. Then what? There exists a pumping length P for L. All right, now what do I do? Pick a string. With what properties? At least P characters and in the language. So what's an example string that would work?
0, 1, 1 to the P, and then 0, 1, 0 to the P minus 1.
So that's a perfectly valid one. 0, 1, 1 to the P, 0, 1, 0 to the P minus 1. This could be P plus 1 and P. Both of them are completely valid. There's nothing wrong with either one. As long as it has length at least P and is in the language, so we're totally fine there. So quite a few people missed points because they picked a string that isn't in the language or it's not long enough. Pick a string that's long enough and is in the language. That'll guarantee you points. All right. So the vast majority of everyone did this. So we have x is 0, 1, 1 to the A, y is 0, 1, 1 to the B, where B is at least 1, and z is the rest of the... Let's do the P and P minus 1, 1. P minus A minus B, 0, 1, 0, P minus 1. That is one decomposition. Or it's a bunch, but it's not every decomposition. Why is it not every decomposition? Could x be some number of characters that is not a multiple of 3? Mm-hmm. Could y be a number of characters that is not a multiple of 3? As long as it obeys the rules, y has length at least 1, and xy has length at most p.
So the decompositions for like 2 characters and 1 character?
That you'd have to handle all decompositions. Okay? So there are a lot of cases here where x could start with a 0 and, well, it either is the empty string or starts with 0. If it's the empty string, then y has to start with a 0 and be and somewhere else. We need to handle all those cases. But I think there's a much, much easier way than just handling all cases here. Anyone have an idea of what we could do to handle all cases so this idea doesn't work? Well, what does y have to be that we know about it? Has to have length at least 1. Oh, where is y in this string w going to guarantee to be? Somewhere. In the first part, in the 0, 1, 1 to the p, could we pump in such a way that we get something other than p 0, 1, 1 substrings? Well, let's see. What if we pumped up? Would that work? No. Why would that not work? Well, it stays in the language with what decomposition, though? Give me an example of a decomposition where you stay in. How about x is the empty string, y is a single 0, and z is the rest of the string? If you put many zeros at the beginning, do you change the number of 0, 1, 1 substrings? No. So I never left the language. So I can't pump up. What about pumping down? What if we pump down? So consider for any decomposition, any valid, I'll say, decomposition of w into x, y, z, the string x, y to the 0, z. So we're pumping down. There are other proofs of this, but this is one proof. Well, if I pump down, well, I don't know what it's going to equal because I'm handling any decomposition. Well, let's see. If y no matter what y is, it must contain some character. So if it includes, let's say, a 0, if I pump down, does that change the number of 0, 1, 1 substrings? Yeah. So if y contains a 0, then the number of 0, 1, 1 substrings decreases by at least 1. I don't know what that is, yeah.
Are you doing the first or the second
second part
First.
deals with the substrings. The first part deals with the actual.
First.
Okay, so that would actually take it out of the language.
Yeah, if it happened to contain a 0, yes. Well, if it contained a 1, either one of them, would I still get the same conclusion? Yeah, if I removed, let's say, if it happened to include that one right there, the second one, well, we just removed a 0, 1, 1 substring. And so therefore it left the language. So same conclusion if y contains a 0. Uh-oh. Well, it better be the same conclusion if it's the same statement. All right, if it can, same conclusion if it contains a 1. Are there any other possibilities? If it has a 0, it has a 1, could it have anything else? No, there's no other characters. Could it be the empty string? Could y be the empty string? No, so we've exhausted all cases. So, in all cases, x, y, 0, z is not in L. I think I called it L1. So I should put a 1 on all these. And so therefore L1 is not regular. Okay? Any questions about that? So remember, you're handling every decomposition, not just one of them where it happens to have a length that is a multiple of 3. You have to handle every decomposition. And just by saying, well, if I happen to remove at least a single character, do I leave the language? The nice thing is that we could use the value of I equals 0 in all decompositions here, and it always works, but it may not work every single time. But yeah, in this case it does.
Is there some pattern to recognize when you should pump down versus pumping up?
Usually the case when that happens is if you have a n+1 and an n there. So like when you pump down, then since you have to pump in the beginning part, then the number of whatever you want in the beginning goes down by 1. And so it must leave the language because you have n of something and n of something where you wanted n+1 and n. So it must have left the language. Yeah. Other question, yeah.
Do we have to take into account the possibility that if y is a 1 and we remove a 1, we might also increase the 0, 1, 0 substrings? Since it's 0, 1, 1, 0, 1, 1.
Well, it wouldn't matter. It wouldn't be equal because we're decreasing the number of 0, 1, 1s. Even if that increased, there is not going to be an n+1 n relationship anymore.
So it doesn't matter.
Yeah, it doesn't matter.
Okay.
Yeah. As long as we can guarantee the 0, 1, 0 didn't also decrease, but in which case it couldn't have because we never touched that side. So we're all good there. Other questions?
So when do we know when we have more than one decomposition?
You have to handle every decomposition every single time. What I think you're asking is that handling every case, when it's not all the same character. Like if the first P characters are not all the same, then it may be the case that one starts with one character and ends with a different character than the other one. But if they're all the same character, then you can only pump that one character. Yeah. Like I said, everyone missed this question. So, but someone asked, I don't know who it was, about the second part, part B. So this one, so a lot of people, I was surprised, people said that L2 equals L1. Are they equal? No, it's a subset. It's a subset. Does that tell me anything about whether it's regular or not? No. Here's an example. Sigma star is regular. All non-regular languages are subsets. Every non-regular language is infinite, and so therefore all finite, hence regular, sets are contained within them. So therefore, just because it's a subset of something doesn't imply the regularity or non-regularity of it. So for this one, L2 was the language of same number of 011 and 010 substrings. So it's not necessarily, oh no, not same number.
One more.
Yeah, you're right. I wrote the test. Exactly one more 011 than 010, thanks. So these, it's not necessarily 011 n plus 1 times, then 010 n times. This could be in any order, okay? Well, did we see a way of using L1 and L2 to help us here? Yeah, we used closure under intersection with a regular language to help us here. Well, if we consider L2 intersect 011 star, 010 star, well, I know that that second guy is regular because it is a regular expression. All right. Well, what is this equal to? Same number of 011 substrings. Oh, sorry, exactly one more 011 substring than 010, and the 011s come first, followed by the 010s.
L1.
That's L1. If L2 were regular, then what can I say about L1? It must be regular by what?
By closure under intersection.
Exactly, closure under intersect. But we know by the first part L1's not regular, so there's no possible way L2 could have been. Okay? So what I was trying to get out of you guys was proving it directly and using closure properties to prove it. I don't think any one person got any of the parts. So review the solutions when they're posted. Okay? Other questions about the midterm?
Yeah, the question about homomorphism.
Yeah. Mm-hmm.
What would be the best way to prove that?
So it's actually pretty cool. So idea of homomorphism is each character in sigma star is no, not every character. Every string in sigma star is mapped to some other string in gamma star. So strings match with strings, but that also means a character is matched to some string. Okay? I don't know what that is, but I know it's a fixed string. So what do? So I can actually draw it. So this is question 6. So if we see a character like A here on a transition, because we assumed L is regular, there's a DFA, let's say, for it, then let H of A, the homomorphism on A, be, I don't know what it is, but let's call the characters H1, H2, up to HK. I don't know what it is. It may be the empty string. I don't know. I'm still moving this down. All right. Well, I want to mimic, I'm doing the homomorphism on this transition. So any ideas of what I can do? What I do is I put a bunch of states in the middle. H1, H2, H3, HK. Does this give me at the end a DFA? No, because it could be the empty string on any one of these, and I don't have any other transitions coming out of here, because these states are going to be new every single time I look at a transition. I put a bunch of states in, possibly. So I made an NFA, but does that change anything? Yeah, exactly. It has an NFA. We proved equivalence with DFAs. Therefore, H of L is also regular. So a lot of people wrote closure under concatenation. That was a great idea because it really is a bunch of concatenations used here, but the fundamental idea is we're simulating the transition we would have normally taken with the homomorphism one. Okay? It's kind of like question 5 on Pset 1, where we're kind of simulating the transition in a different way. But we get an NFA out, but that doesn't change anything. Other questions? It's a pretty cool problem. That's why it was a bonus. So if there are no other questions, then we can talk about regrades, because I know a lot of you are thinking that. So let's talk about regrades. Yay, regrades. So I'm just going to keep moving this down for the rest of the next 2 hours. All right. So if you want to regrade, here are the steps. So these are in the syllabus as well, but I'm going to reiterate them here. So review sample solutions when posted, when I stop being lazy. So if after step 1, you still want a regrade, give the paper to me, that's me right here, by Wednesday next week. The paper will be regraded from top to bottom. Whatever, not just that, whatever the new grade is, it is final. And it'll never be changed after that under any circumstances. And you can't bring it to me if it was written in pencil. Okay? Any questions about the regrade process? I would have said Monday, but I realized it's the weekend and the solutions aren't up, so I figured I'll extend it to Wednesday. Seems fair. Any questions? Yeah.
I think Fair is asking, is it possible to lose points on
Yes.
that?
Yes. Whatever it ends up being. Yeah. It could be still the same too. And whatever it is, I'll still apply the curve that I applied exactly the same way. So it's not like you get the exact same score and now it goes lower. It's I'll apply it the same way. Other questions? All right, I think that was enough midterm. Good stuff. If there are no other questions, we'll move on. All right, so finally we can get to this. So what were we talking about Monday and Wednesday? Yeah, Chomsky normal form. That's the thing that we've been talking about, and let's remind ourselves what the rules types could be. It's the start variable can make the empty string. It's the only way to make the empty string. We could have any variable make a single terminal and nothing else. Or we could have a variable produce nothing else in that rule, I mean. Any variable can produce two other variables, maybe other variables, where the two variables on the right are not the start variable. Yeah.
I asked this in recitation, but when for the third rule, can it be more than two variables, or?
Once you have it in CNF, it'll be exactly two variables. Yeah. Yeah, so the last two steps that we'll do today are making sure that it's only variables on the right-hand side, then breaking up the long right-hand sides to get all the way down to two. Well, should I allow for one variable? No, why? that's a unit rule that we talked about on Wednesday that we tried to get rid of before because we want to actually make some progress instead of having these rules where the derivation is exactly the same length at any given moment. Okay, so here's CNF. And after step 3, we last time had this grammar, this context-free grammar, where we first made a new start variable because we had the original start variable on the right-hand side, can't have that. Then we had, after that, a non-start variable making the empty string, and then we fixed that. We also had some unit roles, and we fixed that by looking at a directed graph representation of the grammar, and then looking at paths in the graph, and then mimicking the rules that way. So is the grammar right now in CNF? No, we have quite a few problems to work out. Like, for example, right here we have a mix of variables and terminals. We can't have that. We have, like this rule S0 goes to SS, that's a perfectly fine rule. But we have ones over here like this one, where we have 2 terminals, but we only want 2 variables or exactly 1 terminal. So what we're going to do in these last 2 steps is work with those 2 things that we need to fix. So step 4 is ensure the right-hand side of every rule is either empty string in the case of S0, a single terminal, or only variables. So we're not going to go right now down to 2 variables. And this is actually where I kind of diverge from the CSE text. CSE merges steps 4 and 5 together. So into one step where you do both of them at the same time. I'm going to separate them out because it's easier to see. So we're not going to go all the way down to 2 variables in general just yet. We're going to have only variables on the right-hand side, or a single terminal, or the empty string. So if we have this grammar right here, what do you think would be a reasonable idea if we want only variables on the right-hand side and no mix of variables and terminals?
Create a variable and have it generate one of the terminals.
Exactly. If we replaced each occurrence of these terminals up here with a single variable that only makes that single terminal, then it'll only be variables on the right-hand side anyway. And we're good in the new variables that we make because they make a single terminal, but that's okay for CNF. So let's copy and paste our grammar down. So I'm going to be making edits to this grammar. I'm just making a copy. So how many terminals do we have in this grammar? Yeah, 2, left parentheses and right parentheses. So the usual convention is let's make a brand new variable that only makes the left parenthesis and another one that makes only right parenthesis. So we're going to have a variable called u sub left parenthesis because I want to indicate them to myself that that makes the left parenthesis only. Oh no, that's right. I'm going to have left. I'm going to have that make left parenthesis only, and u sub right parenthesis make right parenthesis only. So where should I be making edits up here? Yeah, it'll turn out actually in this case everywhere I need to make a fix. So here, I'm going to make u sub left parenthesis, u sub right parenthesis. Over here, because there are 2 terminals, I'm going to fix both of them. And since it's essentially a copy down here, I'm going to make the same changes down here. Imagine someone walking by and looking in and looking at this and freaking out. It's not English. But the idea is pretty simple. We're just simulating as though that terminal existed, but just with another variable there that only makes that one thing, that one terminal. Okay, what if we had, so I'm going to be making an augmentation to the grammar, but I'm going to remove it in a second. What if we had a single terminal on the right-hand side? Should I fix that with the variable like we did before? No, why? Unit rules. Because I already removed them in step 3. So I'm only going to make changes if the length of the right-hand side is at least 2 in length. Well, could the right-hand side's length be 1 and not a terminal? If it's not a terminal, what is it? Variable. Could I have exactly one variable and nothing else? No, because we already eliminated unit roles. So the right-hand side is either the empty string, a single terminal, because I'm not going to replace those, or only variables now. Okay? Does that make sense? 2 people said yes, so therefore everyone did. But does that make sense, though? Okay. Well, is this grammar right now in CNF? No, what's the problem? Yeah, we have a couple instances of 3 variables here. We need exactly 2 variables, not at least 2. So what would be a reasonable intuitive idea for trying to break up that right-hand side to be exactly 2? What we could do is have one variable make a brand new variable make those 2 variables, and then make a replacement like we just did here with terminals. So, step 5. Yeah. Oh, I said I eliminated it and then I didn't eliminate it, so yeah, that's not supposed to be there. That was just to show an example. Okay, well, the last step is break up long, quote unquote, right-hand sides. And long in this sense, yeah.
Does this include like getting rid of the redundant steps? Or?
Yeah, well, we kind of eliminated that because we aren't replacing single terminals with a variable because that would reintroduce unit roles.
I just don't understand why we have to keep, like S goes to SS and S0 goes to SS.
Well, there's no redundancy here. Oh, yeah. So this is just an algorithmic process, like all the processes that we've seen so far. This is just it works for any grammar.
Okay, so.
But we do need this SS there because that would actually change the grammar. And we do need this SS because, we need that SS because we could have exactly 2 applications of things involving S only. And the only way to do that is with S0. Because at this point, every single variable is going to make at least 1 terminal. And so therefore, if I go from S0 to SS, then apply S to SS, then that's going to make more than just the single SS that I had. Because S now cannot make the empty string. So if I have 3 S's instead of 2, that makes more by definition.
Okay, yeah.
Yeah. Yeah, so it's actually pretty cool that we can actually figure out, there's a nice exercise in the book that you can figure out exactly how many rule applications in order to get a string of a certain length. But I'll leave that as an exercise. All right, so break up long right-hand sides. So I'm going to copy and paste the grammar that we have here down here. Hope this works. All right. So the clear problem right-hand sides are the ones that have three variables on the right-hand side. So what we're going to do is we're going to make a brand new variable that makes u left parenthesis s. So, and I'm going to call it y1, and I'm going to have it make u left parenthesis s. And then what should I do with the u left parenthesis s at the top that I just circled? I should replace it with y1, yeah. Sweet. So we're able to break up one problematic right-hand side with two that are correct. If I had, let's say, 4 variables on the right-hand side, how many new variables would I need? I would need 2. 1 to break it down to 3 variables now, and then 1 more, like we just did here, to break it down to 2. If I had n variables on the right-hand side, I would need n minus 1 new variables. Because each one is going to, intuitively, is going to make one more variable progressing down the line. I'll actually make an example of that. So if we happen to have s, 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 s over here, well, what could I do? I could have one variable make ss, and then use it twice. Or I could have one variable make ss, then whatever that is, I make one variable that makes that new variable then s. Both are perfectly fine. But I should be careful here. It doesn't change the correctness if I use the same variable that I created over and over again. But should I make a brand new variable every time? It'd be algorithmic, and there's a reason, another reason that I'll get to shortly. So, is there another, other than the SSSS that I'm going to get rid of, is there another problematic right-hand side? Yeah, the other u left parenthesis. So I'm going to make a brand new variable called y2 that makes the same thing as y1. Again, I could have used y1 here, but I'm going to make a brand new one here. Yeah. Is there a reason why I want to do it this way? Well, it was algorithmic, but how can I ensure correctness here? Well, let's see. If I wanted to apply y1 u sub right parenthesis, then there's only one way in y1 and only one way out. If I had y1 make multiple things, then I may have multiple ways out, and I can't guarantee I can't guarantee correctness. I know it's correct, but I can't guarantee it. I can't prove that it's correct. Whereas here, I know there's exactly one way in and one way out. Okay? Any questions about that? Is this grammar in CNF? Yes. Did we change the language at any step along the way? No, because we ensured that if we had a derivation before, we have a derivation now, and the other way around. So that's good. Oh, does this process work for any context-free grammar? Yeah, so therefore, a theorem, any CFG can be converted into an equivalent one in CNF. This will turn out to be extraordinarily useful. I think this might be the second most important theorem of the class because it's going to be used quite a few different ways. You got a question?
I did. I was just wondering, so again, for the y1, y2, just to be clear, we're doing that because for the same reason why we would want to do a new one for like SSSS.
Yeah, it's just to ensure correctness. You could use y1 in both of those places. You would have one fewer variable and one fewer rule, but it's just to ensure that you are ensuring that there's only one way in and one way out for correctness reasons. But it wouldn't change anything. Yeah.
So for correctness on exams,
You should make a new one, yes.
Now that we've kind of come full circle and learned all the rules, could you go over one more time why we even need the ability to convert CFG to CNF?
Yeah, quite a few reasons. One of the reasons is that we know exactly how many rule applications it would take to get a certain string, whereas with, like, say, that ambiguous grammar that we had before, we had infinitely many ways of making the empty string. Whereas here, we know exactly how many rule applications it is. So I'll actually tell you, I won't prove it. So for any string W of length n strictly greater than 0, that's important, it can be derived by a CFG in CNF in exactly 2n minus 1 rule applications. And so, actually I can prove this. Let's prove it. So, how do we prove this? Well, just to get it out of the way. If n equals 0, what is that string? What is the only string of length 0? The empty string. How many rule applications would it take to get the empty string? S to empty. Start variable to empty. That's 1. Is that going to always be true of any grammar in CNF? Yes. So we know exactly how long it takes to make the empty string. But now let's consider a string that has non-empty length. So let W equal W1, W2, up to Wn. Well, what does a derivation look like? Well, since it has non-empty length, it would have to be S2 either a single terminal, in which case it is 2 times 1 minus 1. So therefore, we're already good there. But let's say it has length longer than 1. Then what does S have to generate? Well, it can't be the empty string. Can't be exactly 1 terminal. What does it have to be? 2 variables. So let's call it capital W1, capital W2. Let's assume we're doing a leftmost derivation. It doesn't matter here. What does W1 have to make? Well, either a single terminal or 2 variables. So it's going to make W1, let's say W2. I don't know what these variables are. They may all be different. I don't know which one I'm applying. But in a sense, I'm progressing one further along every single time. So eventually, I'll get to a situation where I'll have all these variables where each one is going to make exactly 1 terminal of the string. Because it can't make more than 1 terminal at any given, in exactly 1 rule application. So how am I going to get from this string, which is only variables, to the string W, which is only terminals?
Each of those rules have to have a terminal.
Right, yeah. I'm going to have each one of them in turn make exactly 1 terminal. So let's say the first one is going to be the very first variable. And then, since I can only apply one of them at a time, I'm going to work with one at a time, like this. And then eventually I'll get to the string which only has terminals in it. Well, how long did it take me to get from the start variable to where we only had variables? So here's a hint. I started with 1 variable, and I gained 1 every single time until I got to n minus 1. And now I'm going to make every variable go to exactly 1 terminal, and I can only do 1 of those at a time. How many is that? because I'm going to make one of them go to a terminal at every step. So that's n. So hence 2n minus 1. And we're going to be using that for several reasons. So that's one thing. To answer your question more, we're going to actually use this, believe it or not, to prove that some languages are not context-free. By the fact that we can turn any CFG into CNF. So then we'll be analyzing context-free grammars in CNF. What's another one? First and follow sets are much easier to compute if the grammar's in CNF. The grammar is less ambiguous because the empty string can only be derived in exactly one way. There are many benefits of CNF. Yeah. Does that answer your question?
Yeah.
Yeah. Other questions? Yeah.
Question up on top just for
Yeah.
practice.
Uh-huh.
You put down Y1 is you left parenthesis S.
Mhm.
We're not including the U right parenthesis.
No, because I only want exactly 2 variables on the right-hand side. So we had y1 make 2, and then we replaced it above. Yeah. Yeah.
So I had a question about the kind of uniqueness of the Y1 versus Y2.
Mhm.
If you had, say, the Y1 character repeating on the S0 line, you could reuse it with Y1 on that same.
So if like I had a y1 over here or something, is that what you mean?
Yeah, exactly. I mean, you had something that would be equivalent to the Y1. Like in a multi-character.
I would avoid it,
We'd avoid
but
it. So
it's not wrong to reuse it. It may be wrong if you use y1 or with the right-hand side of y1 with something else. But it's not wrong in the sense of the grammar being wrong to use y1 over and over again, but it's just easier to verify correctness if you use it exactly one place.
got it. So it's not across rules, but it's actually every instance of that.
Yeah. Mhm. Yeah. Well, we did avoid the problem here where we used that single variable for each of the terminals. We reused that guy because we know that it can only make one terminal. I should, for uniqueness reasons, you're right, of using a brand new variable every single time to make that exactly one terminal. But since it's only making one terminal, there's nothing else it can make. Whereas with variables, they can go off and make other things. So that's why. Other questions? I think this is a great time to take a break, and then we'll talk about a new topic after that.